How's it, grade 12s? Today we're going on to remainder and factor theorem. Okay, so just to get some terminology out of the way. A polynomial is an expression consisting of a number of terms that can be written in the form a0 plus a1x plus a2x squared and so on. Now, where this a0, a1, a2 is just some kind of coefficient. So you guys have seen, like, for example, 7 plus 2x plus 7x squared. That's all it means, okay? If xn is the highest power of x in the polynomial, then the degree of the polynomial is n. So, for example, if you have x squared plus 2x plus 7, then the degree of that polynomial would be 2. It's just your highest power, okay? For example, here, our highest power is 4, so it's of the 4th degree. If f of x is a polynomial, then the zeros of the polynomial are the values of x for which f of x is equal to 0. You guys have done this for me before, when you set something equal to 0 and then you solve for x, and at the end you say x is equal to or x is equal to, and so on. A polynomial of degree n will have n linear factors and therefore n zeros, of which some may be equal or non-real. So, for example, when you solve a quadratic, an x squared one, okay, you'll always get 2 solutions, x is equal to or x is equal to. If we go into cubics, you should get 3. And if you go up to the power 4, you should get 4, and so on. Okay? Right, so the Euclidean property. Just try to get that into shot for you guys. All right. So the Euclidean property, f of x is equal to d of x times q of x plus r of x. All right? Dividend is equal to the divisor times the quotient plus the remainder. This is known as the division algorithm. So, for example, 15 divided by 4 is equal to 3 plus some remainder, which is 3. So that's your dividend, your divisor, your quotient, your remainder. If the remainder is 0, then d of x is a factor of f of x. So, for example, if we took here 15 divided by 5, and we would get 3, remainder 0. That means that the 5 is a factor. All right. Okay, so example 1. Find the quotient and remainder if f of x equals x cubed minus 4x squared plus 5x minus 2 is divided by d of x, which is equal to x minus 1. Now, grade 12s, I know you're going to hate me, but this is the only way that, or the nice way that we can do it. We're going to have to use long division, okay? So I just want to write out, this is example 1, I just want to write out what our f of x and our d of x is. So we've got f of x is equal to x cubed minus 4x squared plus 5x minus 2, and then our d of x is equal to x minus 1. So what we want to do is we want to find the quotient and remainder if this thing is divided by this thing. So if I set it up into the old way of doing division, we've got x cubed minus 4x squared plus 5x minus 2. Okay, and then we can just draw a little division thing. And then outside that we'd have x minus 1. All right, guys, so it's not too bad if you follow the method. So what I'm going to do is I take this first one, this x cubed, and I divide it by this first one here, x. So x cubed divided by x is x squared. Okay. What I do now is I multiply this one with both of these. All right, so x squared times x gives us x cubed. X squared times minus 1 gives us minus x squared. And you see how it lines up. We've got x cubed with x cubed, x squared with x squared. All right. Then what I do is I subtract this one over here. Okay, so if I subtract this one becomes a minus, and this one becomes a plus. So x cubed minus x cubed cancel. Minus 4x squared plus x squared gives me minus 3x squared. Okay. Now I start the process all over again. I take this one divided by that one. So minus 3x squared divided by x gives me minus 3x. Then I take this one and I multiply it with both of these. So minus 3x times x gives me minus 3x squared. Minus 3x times minus 1 gives me plus 3x. What I do now is I bring this one down. So that becomes plus 5x over there. Okay. Then I'm going to subtract this one over here. So if I subtract this, this one will become a positive, this one will become a negative. So minus 3x squared plus 3x squared cancels. 5x minus 3x gives me 2x. Then I start the process over again. I take this one divided by this. So 2x divided by x gives me plus 2. I take this multiplied with both of these. So 2 times x gives me 2x. 2 times minus 1 gives me minus 2. I bring this one down. Then I subtract this one over here. So if I subtract that, that becomes a minus, that becomes a plus. So 2x minus 2x cancels, minus 2 plus 2 gives me 0. Now, what that means when I'm getting a 0 there, that means that my remainder is 0. That means that this f of x is divisible by this. In other words, this d of x is a factor of f of x. Okay? So the question was to find the quotient and the remainder. So the quotient, q of x, will be equal to this thing here that we got out there, which is x squared minus 3x plus 2. And our remainder is equal to 0. All right. Let's just find example 2. So example 2 is saying, write f of x in the form f is equal to d times q plus r if f of x is equal to this x cubed plus 2x plus 7, and it's divided by d of x, which is x plus 3. Okay. Let's get a new page here. All right, guys, just going to write it down. So we've got f of x, this is example 2. F of x is equal to x cubed plus 2x plus 7, and our d of x is equal to x plus 3. Okay, so I'm going to draw up my little division thing. Now, the thing I want you guys to notice with our f of x is we've got an x cubed, we don't have an x squared. We've got an x and then we've got the 7, okay? So we're just missing one of the terms. Now, it's important that you have all of them. And what I'm going to do is I'm going to put the x cubed in there. There he is there. But now we're missing the x squared. So it's plus 0x squared. Then we can go to the next one, which is plus 2x, then plus 7. If you look at our previous example, we had all of the terms. We had an x cubed, an x squared, an x, and then something with no x. Okay, so we didn't have to do that there. The reason why we have to do that is when we do our long division, remember that things must line up. We must have a column for x cubes, x squareds, x's, and then the constants. Okay. What goes outside here is x plus 3. All right. So what we're going to do is we're going to take the first one divided by this one here. So x cubed divided by x gives us x squared. Take this one, multiply it with both of these, and we get x cubed. X squared times that gives us plus 3x squared. And you see, that's why I had to fill this one in, because we need that column of x squareds. Right, our next step is we're going to subtract the second one. So if I minus this, that will become a minus, that will become a minus. So x cubed minus x cubed is 0. 0 minus 3 gives us minus 3x squared. Start the process over again. Take this one, divide it by that. So we'll get minus 3x. Take this one, multiply it by both there. So minus 3x times x gives us minus 3x squared. Minus 3x times 3 gives us minus 9x. Bring this one down, and we get plus 2x. Okay, so what I'm going to do now is I'm going to subtract that second one. So if I subtract, this one becomes plus, this one becomes plus. So minus 3x squared plus 3x squared cancels. 2x plus 9x gives us 11x. Start the process over again. Take this one, divide it by this one, so we get 11x divided by x gives me plus 11. Take this one, multiply it by both, so 11 times x gives us 11x. 11 times 3 gives us plus 33. Bring this one down. I'm going to subtract the second one. So subtract, that becomes a minus, that becomes a minus. So 11x minus 11x cancels. 7 minus 33 gives us minus 26. Now, the thing to notice with this one is we are getting a remainder of minus 26. So therefore, this is not divisible by this. In other words, this is not a factor of this. So what we can do now is we can write it up in the form that they wanted, which was this f of x is equal to d times q of x plus r. All right, so it was this thing here. So we have x cubed plus 2x plus 7 is equal to this one multiplied by this one. So we'll have x plus 3 multiplied by x squared minus 3x plus 11 plus the remainder, which is minus 26. So just to recap, this is f of x. This here is your d of x. This is your q of x. And this is your remainder. All right. Right, grade 12s. What I would like you to do is exercise 7.2 for me, please. Numbers 1 to 8. Thank you.